Okie dokie. So we're going to go ahead and talk about some handy dandy Excel tricks. So first little thing, so I have a little table. This is similar to the lab you all are doing in class, but I made it a little bit different just so you guys can figure out more stuff on your own. So a couple things. I measured like two sides. In this case, I measured an adjacent side and a hypotenuse just of the random triangle ramp. That's not exactly maybe what you have, but we'll all have different things. Cool. So now what I want to do is, and I calculated some times that it takes for a marble to roll down this ramp. We're going to go ahead and find the acceleration, the angle in radians, then the angle in degrees, and the cosine of the angle. Some of these things I just added because Excel automatically does things in radians versus degrees, and we'll kind of want, well, actually we'll just figure out, it's kind of nice to have it in degrees just because I can visualize that better, but you can figure out what is most useful for you. Cool. So first thing I want to talk about is average time. So whenever you put an equal sign in Excel, that means you're doing a calculation. So I'm going to type equals and then average. Oh my goodness, and it even gives me like a written definition. Excel is so cool. And then what I can just do is I can highlight the numbers that I want the average of, and then do close parentheses, and then enter, boom, boom, boom. And then I have 2.05, and I can just, this little box in the corner, I can just pull it down and see if it, and then just does it for everything. So cool. I always like to like fact check one more just to make sure my formula is correct. So if I have a 3 and a 3.1, okay, I know the average should be right between those, so 3.05 makes sense. Cool. Okay, so now let's say I have some formula where it calculates, or to find the acceleration. So let's say I have a nifty formula, and let's say this is not correct at all, but let's say I say acceleration is basically the time, so we're going to use the average time now. Let's say it's the average time times 2.3, then divided by the hypotenuse. Okay, again, none of this is correct. It's not actual physics right there, so, but it's just our example. So I'm going to go ahead, type that formula in. So I'm going to say it equals average time. So I click that column with average time, and then times the number 2.3, that magical number 2.3, divided by the hypotenuse, which is this one. And so I click that and then just click enter, and then I can just scroll on down. Okay, nifty. And then I got the acceleration for all those different scenarios. Cool. So now what I am going to go ahead and do, okay, and I realize I did a silly example. For your case, all the hypotenuses may be the same, they might not be the same. I'm just going to change them all to 0.79, and then I'm going to say that I am changing this to 0.3 and then 0.2, let's say. Okay, cool. Sorry, just random example. So now let's go ahead and see if we can find the angle. So I say that, let's say we have a triangle, and this is the adjacent side, and then this is the hypotenuse. So to find the angle, it is actually going to be the arc cosine, yeah, adjacent over hypotenuse. So I can just type arc cosine. Okay, so I'm going to always read this too. It returns the arc cosine of a number in radians, and the range from 0 to pi. The arc cosine is the angle whose cosine is the number. Okay, cool. So I'm going to type in, so it's the number of adjacent over hypotenuse. So it's this divided by this, close parentheses, and then boom, boom. And then I'm going to make sure to do it for each of those. Cool. So I cannot visualize what the heck a radian is. It's crazy, but I know what degrees are. So I'm going to convert these radian measures to degrees. So I'm going to say, now I always have to figure out degrees, it converts radians to degrees. Cool. That's what I'll want. Another thing I can do is I convert degrees to radians, but I already have these in radians, so I'm going to do the opposite. So I'm going to say degrees, and then close parentheses, and then click on the number I want to convert, close parentheses, boom, boom, and then I can just scroll down and see what it is. Oh, cool. So it looks like I am increasing the whatever you call it. I'm increasing the angle. It's getting steeper and steeper. Cool. So the last thing I want to look at is, okay, I want the cosine of the angle. Okay, so interesting. Okay, so I'm going to go ahead and type in equals cosine. Okay, it returns the cosine of an angle. Excel does it. You can just double check, but Excel wants you to put those numbers in radians. Let's just try it in degrees and see what happens. See if that would be right. Yeah, cosine of an angle, we're not going to want it to be a negative. These should all be positive numbers. So we know that's not right. So we need cosine of, it needs to be in radians. So I'm going to click this. Beautiful. Oh, cool. So this is, so, okay, cool. That works. works out. Cool. So now for each of these, cosine of the angle is whatever. And we know, so cool, just going back to some good old math, like cosine of theta is adjacent over hypotenuse, and zero point 0.4 divided by 0.79 is about a half, which is just what this spits out at. Oh my goodness, math is so cool. And then do make, like, it's good to make your good old table, put some, let's see, format cells, put like a good old border around. So let's do a nice little outline border. I like doing the outline in like a thicker color. And then inside border, I like something like that. Cool. And then I kind of like doing like just under the title and stuff like that. Make your title prettier than mine. Mine does not look very good. Format cells. I like putting like a double line underneath just to say, oh, that's different kind of thing. You can have trial, whatever, your table will look different than mine. But this is just a little example of it. Cool. Thanks for watching.